Good afternoon, everybody. My name is Dave Copps. This is Chris Rohde. We're both from Pure Discovery out of Dallas, Texas. Across the pond today to talk to you about BrainSpace. So I'm going to cover a couple things today. Before I do that, I'm going to give you a little bit of history about us, just to kind of let you know where we come from. We're both geeks, if you will, semantic geeks. Before this company, we built a company called Ingenium, which really focused on semantic search as a technology that you learn from information. We were purchased by Marsh & McLennan back in November of 2006, and that's when we had the idea for this company. But that company had, although we felt we had built the best real search engine in the world, it had some limitations, same limitations that a lot of semantic technologies have. And that is that, first of all, you have to index the documents you're searching. So every time you walk into organizations, and you all know better than anybody, you've got probably silos of information. You have to approach the different silos with different search interfaces. And we thought that was broken. So we learned a lot from that company, and we took that knowledge and applied it towards that Pure Discovery. But the big thing today that we're going to talk about is we're starting to realize a vision that we had about 7 years ago. We had this idea when we started to get an inkling of what's possible with semantics, this ability of machine learning to digest information, learn dynamically from it. We had this thought about, what if we could actually put a layer over the web? What if you could actually put where you have a system that learns information on the internet and then provided an intelligence layer that everyone could use. You could use it to make better searches. You could use it to find people more intelligently. And that's what we're working towards. So today we're going to talk about basically three things. BrainSpace. BrainSpace is basically our platform for interest graph. We'll talk about interest graph in a moment here. It's essentially a large-scale machine learning platform. It learns dynamically from unstructured information. So documents, whether it's a web page, or Word docs, whatever you have that's text, it learns from unstructured text. It's a very scalable platform, machine learning platform. We'll talk about some of the things that we've done with it to date. It's been open live for a few years now and being used all over the world. We'll talk about the BrainSpace API. A big shift we're making is we're changing from selling this thing as like a server software. We're going to be now opening up the BrainSpace, giving away the API for free, and allowing anyone, not just ourselves, but anyone to be able to develop on top of the BrainSpace platform. And then we'll talk about Grok. And Grok is a new application that we're building that sits on top of BrainSpace. It's our example of what can be done with the BrainSpace platform. And Grok is a social curation tool. It allows people to socially curate information and on top of the BrainSpace platform, which dynamically learns from your activities as you're highlighting things and collecting things. In Grok, BrainSpace is learning about that, helping you find other things that are related automatically. By the way, we'll make this very interactive. If you have questions, even during, you don't have to wait until the end, just raise your hand and we'll kind of let you even guide a little bit the presentation. We'll kind of try to keep it on the general track forward. Let's talk a little bit about interest graph. Show of hands, how many people are familiar with that term, interest graph? So, about 10%. So everybody knows what a social graph is, like Facebook and obviously things like that. It's important, what we're talking about, we think that the interest graph is the next evolution of a social graph. So the difference is in a social graph, it's mostly about the present and the past. In your social graph, whether it's Facebook or other social applications that you use, you're connecting primarily with people that you know today or people that you knew in the past. Social graph is mostly about connecting people by who knows who. So I know Chris knows you, so I know you know Chris. Social graph. The interest graph is very different. The evolution of the social graph is that now we're going to start connecting people by who knows what. So who you are is really a culmination of your interests. And now you'll be able to express that in a way that you can be discoverable, if you choose, by other people who share your passions. And that's really what this conversation today is going to be about. So why BrainSpace? When we started really trying to fix search, we thought and still believe that search is fundamentally broken. If you think about it, you go to Google, right, you put in your search and you have, I don't know, 100,000 pages of 10 blue links, right? Well, let's get past the first page. So what's the point? Search, even fundamentally, if you think about the premise of search, it's fundamentally broken. first of all, when you do a search, before you push the button, every document that's in the database you're searching is given equal relevance. Why is that? All those documents are equally relevant to you. They're not. Because the system doesn't know how to do it. And search also is, if you think about it, you're putting in words that you know. And you're connected to other documents that have those words in them. It's like a rifle shot to what you know. Where discovery really happens is on the other side of that. Discovery happens in serendipity, where you find something that's related that didn't contain the same words, and so search fundamentally doesn't do that, We've tried to handle that with other engines where they have taxonomies and lexicons and thesaurus and ontologies and things like that, right? But even those are static. There's no one, you're at the mercy of the person building those ontologies and lexicons and things. So, we thought, we can't do that anymore. There's got to be a better way. We have to build a system that can learn dynamically from information as it's published, without the use of lexicons, without the use of thesaurus, synonym, first get these new lips, but without the use of any of the static knowledge, and that's what we've created. So it was really about fixing search, but we kind of became present to a much bigger game. As we started building BrainSpace, we started noticing that a big part of knowledge discovery is who's doing it, who they're sharing with and collaborating with. So when you hear about people doing social media mining, it's a little silly right now. The way we're approaching social media mining is by counting likes and things like that. What I want to know is who liked it and what are their interests, and does that make this document more relevant to me given what they are interested in? Those are the kinds of things we have to start getting into. So we're launching a platform for interest graph. Inside, we're talking to several people now. We do have a relationship with Reed, and one of their companies, LexisNexis. We were working very tightly with them on all their intellectual property products. Matter of fact, if you do search on any of the IP products for LexisNexis, you're using our technology. So BrainSpace has become a very scalable thing. It's been something we were building 5 years ago. It may be building a learning on a couple million documents. Well, now our largest learning is about 350 million documents. And we think in 2013 we'll be able to build these learnings, these machine learnings, as big as 1 billion documents. That starts to get to a point where you can dream a little bit about the initial vision I told you about today. So some of the things that helped us realize BrainSpace, there was a lot of what ifs. It was, some of the what ifs we had. What if we could collectively learn from documents all over the world that were published? What if we could form a learning from all those documents automatically? What if that collective intelligence could connect people more intelligently to not only other people, but to documents and things that matter? In short, BrainSpace does that. The largest BrainSpace today, again, about 350 million documents. We're working on some that are larger than that. We've actually been given the Science Direct corpus by Reed. We've built a BrainSpace on that. So now the 14 million documents in Science Direct have now been turned into machine learning. So we're doing some very exciting things. We're actually meeting with the nature folks tomorrow afternoon. We're very excited about that. A big part of our trip coming over today. But I thought we'd do, I don't like lectures myself, so I thought what we'd do is, we're going to show you a couple of things today, because I want you to actually kind of see what we're talking about. This isn't just fiction or fun. So before we get into Grok, which is the first application that we built on top of the BrainSpace API, I thought we'd show you something we did recently. This is actually built on top of our BrainSpace API. We received a call from the patent office, and U.S. patent office, sorry. and they had, one of the things that they really are pushing now is small inventors. They want to start supporting small inventors. These are inventors that don't have a company behind them, don't have a lawyer. How can they find out if their idea is patentable? And so we have this idea, kind of a crazy one, you'll see here in a second. When we show it to people, there's a lot of giggling usually, but we try to make search, even semantic search, something that's very accessible to anyone. I have my 9-year-old kid using this, just loves it. So what we did is we came up with this idea of the brain. What if people would interact with the brain? So we took this is actually just about 1 million documents. So we built a to bring on the entire corpus of patents. But this demo is actually just built on about 1 million patents. But we essentially took 1 million patents, put them into our system, it read them. Brain build probably took, let me guess, about an hour. So it's very, very fast. So it built this intelligence and machine learning about what it read. And now people can interact with it. And I'll let Chris kind of take it over from here.
Absolutely. In a second, we're going to need to plug it so we don't run out of power. And for those of you in the last presentation, this looks a whole lot better than it did before. So the idea behind the demonstration is that you can take content from anywhere on the web. Literally, it doesn't matter what site you're on, or frankly, a document on your desktop. In this case, it's an article specifically around volcanoes and the technology associated with how do you monitor volcanic activity. But the idea is that you can take content from anywhere. And let me move it over a little bit so you guys can see the brain. You can literally drag the text to the brain, and if you let go, the brain will automatically connect you to the material. So again, this brain has been built on a little over 1 million documents, primarily patent information, prior art material, and so it automatically connects you with the material. You can see the content over here in the upper left, right? That's actually my query. In the middle of the screen, these top terms, these are all terms that the system knows to be associated with the content that I used as my query. Although many times those words and phrases don't actually appear in the content at all. And that's a really important differentiator, right? Is that it's conceptually matching the article to the material. And then of course I have my results over here on the right-hand side of the screen. Now, one of the key pieces of BrainSpace, one of the things we're most passionate about is this ability for the end user to drive the experience, for them to really say what's most meaningful to them. So in this case, I have things like CBN, volcano, volcanic activity, eruptions, St. Helens, obviously famous volcano in the US, and volcanic gases. But the idea here is that the end user can control the experience by simply taking the lever and you drag it to the right. It makes something like volcanic gases be more important. And frankly, if Helens is not that important, or St. Helens is not important, I can drag all the way left and it'll ignore that, right? So the whole idea is that the end user can communicate directly with BrainSpace through dragging the levers back and forth. And then of course, you have the available result set, right?
Before you go on, this is something we really worked on for a long time. Those of you that have kind of used semantic search in the past, it's largely described as a black box. Like you have a document you're interested in or a paragraph, you say more like this, and it goes and grabs more stuff. But you have no idea how it achieved your result. Sometimes it's bad, sometimes it's good, and you want to know why, and you don't know why. So semantic search is favorite for this black box. Early on, we decided we didn't want to do that. We want to give people, the researchers, the scientists, people using our products, the ability to interact directly with the machine learning. So we've, in all honesty, it probably took almost 2 years to figure that out, on how to have this present itself in a way that humans kind of think the same as machines. It's a lot harder than it sounds. So now we do this. BrainSpace not only pulls some of the words from your corpus that you use as your search, but then it also surfaces an inference of lots of terms and phrases that are related to what you're looking for that were not your query. And it's learned that from the entire corpus.
So, and of course, you can click on the actual document, you'll see the abstract up here of the actual patent. From there, it gets really interesting, right? The ability to take that abstract and to do one of two things. One is to save it off to a collection, and we'll talk more about that in just a minute. But that's where Rocket really takes over, and the ability to save documents to a collection and then have those collections become a part of BrainSpace and attract additional material is kind of the core of what we do. And then the other piece is, of course, just searching prior art. So if I use that patent as my query now, that uses the patent up here as my query, my top concepts have all changed, and now I'm looking at prior art literature, NLP literature that's sort of closely related. A couple other useful elements here. The timeline view, which actually isn't active right here. This is actually an image. But the intent is to have that context sensitive so that you'll be able to drag a little magnifying glass over the period of time that you're most interested in. But the histogram gives you a real good understanding of kind of how a concept is transpired over time. So it can be very useful in research. That's going to be prior. that's a really quick kind of introduction to BrainSpace.
Yeah. So the next thing, well, actually, any questions so far about BrainSpace, machine learning, or methods or anything? Yes?
It's oriented towards pattern, is that correct, or is that just
Yeah. BrainSpace, his question was, is it oriented towards patents? BrainSpace learns from anything you give it. So in this demo, we actually learned from a million patents. But like I mentioned a moment ago, we built a brain on Wikipedia. We built a brain on the entire corpus of Science Direct. We built a brain on the entire corpus of patents.
it's like more a use case that you started with?
Sorry,
Is that more like a use case that you started with? That you had
That's
in
right.
mind, right? I mean, you can tell from the UI.
yeah, that's right. Yeah. This is just giving you an example of how it worked in that particular use case.
I was interested to your relationship with existing ontologies. You said that you basically kind of didn't use them at all, and you said there were obvious pragmatic reasons for that in certain domains, but obviously in quite a lot of science and medical domains they're very strong ontologies. How do you relate BrainSpace to existing ontologies?
Yeah, it's a great question. Our technology by itself doesn't require them to work. I guess I probably should have said it that way. We don't require any ontologies. It learns dynamically from the documents. You put documents in database, point BrainSpace at it. It builds basically a hyperspace of about 300 dimensions. And so it's like standing in a sphere and having words and phrases floating around. So when you ask me a question, it goes to the area of the hyperspace and pulls out all the words that you need, phrases. But we do have the ability to work with ontologies or lexicons. If people have a business where they spend a lot of time and money building those, we can actually use those to mark up inside the brain. It's kind of interesting is, I'll give you an example of one of the things we're talking about now is like symptoms. There's an ontology of symptoms. And what BrainSpace can do, if you gave it an ontology of symptoms and then had it, like say, in a science corpus, or a medical corpus more accurately, it could actually then start to associate the symptoms that are related to certain diseases. You see what I mean? So you can actually use the ontologies to give BrainSpace a kind of a marked up learning, if you will. Now it's going to know that this is a symptom, and it's how it related. Now we'll judge the distance between that symptom and diseases or medical. A couple of questions here.
I'm going to ask a question all the way down.
Okay.
Coming from a library standpoint, libraries have done a lot of this work in ontologies. So I'm curious whether you've worked with any libraries because there's starting to be a loss in serendipity as people move primarily online and things like that. So one of the things I'm interested in is how can you take that system that's already in place, build on top of it the pieces where something like this would be really useful to connect some of those ideas and to see what would come out of it. So has any library turned over their entire catalog to you, or would you be interested in that?
Yeah, we would be interested in that, and we're talking to some libraries now. The short answer to your question is we don't. I hope no one ever sees me as a person that thinks that technology solves all problems. I actually view technology as an enabler of people. And so when there's a system like that that's already in place. I mean, imagine how much better it could be if now those documents that are sitting there in our brain, and now that everything you do can be guided by the brilliance, the thoughts and the concepts and ideas that are in that corpus. It just makes it a better experience. I also think, we've talked to the SLA people for a long time, and it used to be kind of threatening. They thought there was someone that was trying to take over the job or something. It's exactly the opposite. This is another wonderful tool for librarians to use to actually probably spend more of their time on things that matter and less on, because I think they spend, some stats we have on search is 30 to 40% of the knowledge workers' time is spent on search. 30 to 40%. Multiply that by a salary, you can start to see the amount of time that's spent searching. If you could take away or condense some of that time searching and use that other time for things that really matter, I think we help out. But we're very interested in working with libraries.
All right, you said you had an organization that was searching all of the content on Science Direct, but Science Direct contains many subscription journals. So are you searching abstracts only or full content? There's obviously implications here for open access.
There's not an application presented out to the public right now. all we've done, to be very clear, is we've been given the Science Direct corpus, the full corpus, not just abstracts, and we have built it into a brain. So we have in our offices the Science Direct brain, and we're in discussions on what we're going to do with that. I'm not free to say what that is right now, but it's a good. You'll be very, very excited about it.
We have to pay for it.
Yeah, that's exactly right. We're talking about, especially the ability, you can use BrainSpace, searching abstracts is useful. And that is certainly could be a first step. Okay. So the next thing, now to kind of understand BrainSpace, is now what we're going to talk about is Grok. Now we do have an open API, so anyone that wants to build on top of BrainSpace can. We made that decision just last year because we're about 16 people, 17 people right now, and for us to build vertical market applications for lots of different vertical markets would be ridiculous. We don't have the people to do that. So we instead have chosen to open up BrainSpace's platform and let anyone that wants to build applications on top of it. So if you have a collection of documents you want to build into a brain and put an application like this on top of it, you can do that. You can also build an application like this. So we're completely opening up the API, and we're very excited to see what comes from that. So does anybody know where the word Grok comes from? Any science fiction geeks in here? It's actually from a science fiction movie in the 70s, I think it was, called A Stranger from a Strange Land. But it means to deeply understand something. So we chose that word because, in social media you have the like button, right? And I don't know, I got so lost in that. And there's, what does that really mean? So when you grok something, it means you're really interested in it. And so that's why we chose the name Grok for the product. But Grok essentially is the first application we're putting on top of the BrainSpace API. And we are going to announce we have cards up here on the desk for anybody that wants to. Beta is going to be free. Actually, the first product's going to be free too. So you can sign up for the beta here. You're the first people that are going to get these cards. So Grok basically is a social curation product. It allows you to collect, share, collaborate on content very, very simply. And that one of the things we wanted to do was we didn't want to make a tool per se. You always have to go to a tool to get results. We didn't want to make a tool. We wanted to make something that was a little bit more like oxygen. It's just there when you need it. So we do have a browser button, and you'll see all this in a moment. But the idea behind Grok was to create a tool, to create a product that allows you to, without changing your behavior. Everybody in this room browses the web for information. Well, right now you can enter Grok by browsing the web on your browser. So we have a browser plugin that just kind of lets you highlight a paragraph and bring it into Grok, and it starts building and learning from that, helping you find other things that are related. We make it very, very simple, something that you can do without having to enter into a tool. You don't have to be in Grok to use Grok. Just be in your browser. Chris has left his.
Sorry.
Okay. Someone's died. So while he's doing that, though, there's Dr. Michael Wilson wrote a book recently called Reinventing Discovery, the New Era of Network Science. And he claims in the book that basically we're at the dawn of a new age in science. He said it's the biggest change in 300 years. And that because of the tools today and the way that the connectedness that can be caused by the web and these collaboration tools, that we're going to be able to accelerate discovery and even collapse time a little bit, like we talked about a minute ago in search. And I think this fits right into that category.
Perfect.
Go for it.
And we have power now too. So this is Grok, and anyone can log in. We have invites here on the table. Actually, when you log in, you can either choose a username and password yourself, or you can actually use your Twitter ID. So feel free. The advantage of using your Twitter ID is the system itself can learn an awful lot about you and start to understand kind of some of your interests. So when you log in, you end up with kind of this front page, and looks a lot prettier than before. The idea is that it's like the front page of your newspaper. I have several collections here I have a collection on cloud computing, on cold fusion, on climate change, TP robots. Right? So, but the idea is that I saved off documents and entered them into BrainSpace. Now, BrainSpace constantly is comparing and relating that to new information as it comes into the system. So, so you can scroll through, get a little bit of a flavor. And in fact, if I click on something more specific, like my TP robots profile, you can see here, this is a collection that's been based on a series of documents that I've collected around robots. Right?
So it's important to know that he's not having to build queries at all. All Chris is doing is he's doing what he normally does. He's reading stuff on the web, and through Grocket he's able to highlight a paragraph he likes and hit the G button in his browser, and now Grocket pulls it in and says, hey, you want to put this in a collection? If you put one of your collections, that collection becomes smart. BrainSpace reads that collection and automatically starts looking for other things that are related to it. So
an example of that is I looked at this telepresence robots article. I picked this up yesterday off the Silence blog. And I use that as the basis of this new collection now, just on TP robots, right? And so just by simply taking one item and putting that in there, now it's starting to understand, it's starting to relate everything in BrainSpace. And today we have live Twitter feeds coming into our office, so we're taking any tweet that has a link associated with documents, and we're bringing that back in and creating BrainSpace as a result of that.
Which, I say something about that. Sorry, I keep interrupting, but that's a really important thing we've talked about. Then they go to the big data session. We have a couple of big data sessions at this conference, and we believe that social curation is one of the cures for big data. And we are really starting to mash together semantics and social curation. So, when a document is published and put out there, people touch it, and they either like it or they don't like it. They either share it or they don't share it. And a lot of documents fall down and aren't accessed at all. So that human layer, that social curation that happens when people share things, tweeting, retweeting, putting something on Tumblr or on your science blog, or Quora, questioning Quora, the document link. Anything you do socially, or Google Docs and sharing it. All that social interaction needs something, and we're starting to learn from that as well.
So the idea here is I have, you see my different collections I have here. But if I go back to the front page again, we can take a look at, literally, here's a front page just built on that one article now, right? That was talking about robots, right? And so you end up with robot-filled coffee balloons, or robots in the New York Times, or here's some Futures magazine that shows pictures from CES, World Future Society, right? The whole idea is that by collecting things that matter to you, you're then automatically connected to related items. And then as you collect related items, this ability to then share that experience with others is essential. So for any collection, you have the ability to share that, and we click on the share button here. This would then allow, for instance, if I created a collection of documents that matter to me, I could then share it with Dave.
I wouldn't be sure about collection.
Yeah, I know. But literally, you just type in Dave for discovery. Interesting articles. Articles.
Robots doing that though. I heard someone talk in the session before last about how a small percentage of science are blogging and doing social media, and it is part of it is a lot of people just don't like to blog, and there's exposure that's there. It's not comfortable to a lot of people, and tweeting's a lot less that way. But one of the things I think that's causing that is that social media right now again is they're tools. So I got to use Twitter to do this, and I got to use this to use that. And one thing we've tried to do in Grocket is to kind of take all that fear away. Like, you can actually create a collection on something you're passionate about. If you want to, you can open it up to be discoverable, so other people can discover your collection. Like when they highlight a paragraph on robots, they're going to find Chris's robot collection. And people can subscribe to your collection. So now, almost like blogging now, right? As you collect documents, maybe annotate them or talk about them, it's a very kind of very low friction way of sharing. collaborate.
Absolutely. So, as Dave said, I mean, I can share via email, I can share via Rocket user if you're already subscribed. If you're not subscribed, you can send it via email or Twitter. You can choose to keep it, to make it public or keep it private, right? Which is really, really important. So that if you have a small group of users that you want to go and you want to collaborate with, that you share it with those folks, you may want to keep that private, right?
Yeah, that's been talked about a lot too, is that, you know, social media is so public. We are going to have Grok such that you can actually create small groups, a group of 10 people, and only those 10 people can share the collection and can contribute to that collection and can read that collection.
Obviously, the benefits of putting them out there for everyone is that people who have similar interests can discover you as well. So this is available for the broad web, or as
Will be
available on the broad web street. You know, we're making it available for enterprises as well, within organizations. A general rule of thumb is, you know, things on the web, you know, going to WebBrain, you have enterprise clients that have, you know, private brains. So, you know, the enterprise content is only within the organization. You kind of alleviate some of the fears that we kind of talked about earlier in terms of sharing research externally or not, or
Right.
Those types of things.
Good question.
Hi, I'm kind of reading this and going, ooh. And the reason I'm thinking this is because I have collections of stuff. I have collections of stuff everywhere.
Yeah.
And I have a massive collection of web pages and documents and things
Yeah.
with tech. I use Evernote and
Okay, I was going to ask you where you put them.
if I have started a collection in something like Evernote, could I put it into Grok? Is that possible?
It's not today, but we're absolutely going there. We are going to create an Evernote product. We love Evernote. I use it. I've used it here. I use it everywhere I go. But we will work with Evernote. And again, we don't view this as competitive to a lot of things. It's kind of, we're taking a different tack. We want, if you're using even Mendeley, you find something, you can highlight a paragraph and, you know, use Grok to find other stuff. It's all just very kind of cooperative. We're not trying to create a silo by any means. We love it.
But to answer your question specifically, you can't manually put those in there today, right? This kind of interface. But for sure, I understand where you're going. I was using Evernote in the conversations, taking a type of A, and we will, of course, intend to use their APIs to allow you to bulk transfer those.
We're talking with some of the newsreader products right now as well.
I think you mentioned APIs. Was that for
BrainSpace.
BrainSpace? Or is that also something you have in Grok itself?
Yes, and BrainSpace actually powers all of the Grok activities, right? So we'll make available all those activities via a set of web services for you to use. So things like sharing and matching documents, measuring collections back and forth, the interaction with the global BrainSpace so that you have access to that as well.
That was APIs for Grok.
Are we going to, we're going there. The idea, what you're seeing right now is not built as like objects, but we're actually going there. What we want to do is have all the things you're seeing on Grok here, able to, almost like Legos, you know, where you can actually pull it into an app and build things like Legos. And we're going to be putting budget and effort into that. But right now, the API allows you to build all this stuff. But yeah, there will be, I wouldn't so much call it an API for Grok, but we'll call it, it's going to be built with these pieces that are objects that you're going to be able to take and build with as well.
But we have a wide variety of folks who are using existing API. Like we have a partner that does social media monitoring, for instance, right? Using the API and plugs that into their interface, and they take some of our elements and build those with their elements. Right?
They're really cool as a company. They took a bunch of their doing. I mean, the Olympics happened, by the way. Great job.
Yeah.
It was awesome. They took tweets from the Olympics. From one day of the Olympics, it was for a client. You shall remain nameless, but and they used BrainSpace to build intelligence on the tweets from that day. You know, it was really interesting because, what was the gentleman's name who had the paddle wags? It was apparently one of the days that he was racing because when you put in carbon fiber, you know, carbon fiber on the web will get back a lot of stuff about, you know, materials and things like that. this brain came back with stuff like
prosthetics
and you know, the weight of the prosthetics, and they put in fuzzy terms like courage, and it came back with like persistence, and and so it's really interesting to see how it learns from the different documents you get. We're kind of it's a fun thing for us to do to start to see different collections, especially back there.
Yes, I was just interested. Could you maybe talk a little bit more about the tech? How are you guys doing this? Is it if you drop a paragraph in, is it scoring words and matching based on word counts? Is that how it works, or is there more to it than that? Or maybe could you just maybe talk a little about that?
Yeah. In terms of the actual math, it's machine learning, right? Most akin to kind of an LSA-ish approach, if you're familiar with the math. But we've done some really interesting things to scale technology that just hasn't been done before. Our largest population to date is on over 300 million documents for a single BrainSpace on a single server, which you know, in most worlds just isn't possible, right? Even for big providers like Attendees or other people. Right?
But we, as Chris said, we kind of started with this idea of LSA, you know, and which is it's linear algebra basically. But we found all things that didn't work. You know, we have patents on things now that kind of really solve some big problems. One was scale, being able to build a machine intelligence like this at one server is kind of amazing that big. But even just inside of that, we have innovations around, you know, like automatic phrasing. Other technologies, when you see a phrase, the reason it recognizes the phrase is because there's an ontology with that phrase in it. We don't have any ontologies. We identify phrases on the fly. So technology looks at words that are highly related to each other, that are happening in sequence, and there's some other stuff obviously that goes into this, but you know, so we're recognizing phrasing on the fly, and then we have.
The other thing that's important, though, is you're pointing out in terms of how you approach text. We have a patent pending on something we call multi-concept search, right? And the idea that if you're using a paragraph of text, most technology will try to find a center point around the entire paragraph. And what we do is we start to understand that really there could be multiple themes as a part of that paragraph of text that really makes that relevant to you, right? It's the confluence of those themes that make it highly relevant. That's another piece that makes that very different.
But to paint a picture for you that's kind of interesting, like with the Lexus brain, they have like 9 different brains. And together they make up a BrainSpace. And if you have a document, you highlight the whole page and say, find more like this, it'll find 2 or 3 or 4, however many there are, unique concepts in that document. What's interesting is each concept can go to a different brain to draw inference and other words that are related. So it's a very interesting system. It's not like, you think it's just like you find some words and you pull some things that are related or synonym lists or something like that. It's actually really thinking.
Did that help?
I'm not a computer scientist, so.
All right.
Oh, okay.
We're happy to talk after this.
I've got a couple of questions.
Sure.
The first one is, what data do you expose? So let's say you've got a collection, you've run a search. Out of these 400 dimensions for the graph, can I get like a little subgraph back of all these connections that I can visualize or I can use myself?
Yeah.
We'll pull you up something we weren't going to show, but yes. So one of the things that really happened over the course of building BrainSpace was we had to learn and get deeper and deeper and deeper and deeper. A few years ago, to be flat out honest about it, sometimes you search on something and the first 3 or 4 words would really be really relevant. You have a couple stinkers, and it was. And over time, now we got to the point where we love to just sit in front of audiences and have people throw stuff at it because it just works every time. And it also goes very, very deep. And Chris is going to show you here something that we built actually for the legal community. But they have this problem. They get cases, with tens of millions of documents, and they have no idea what's in those documents. And so we built a visualization.
And actually, this is Wikipedia. So this is the entire English version of Wikipedia. Okay. So one of the visualizations that we have in another one of our products, as Dave said, primarily used in kind of the legal community. is our wheel here. And the whole idea behind the wheel is that it allows you to explore even very large data populations just simply by browsing. And so this is a map built on 3.4 million documents. And as you click on anywhere on the wheel, right, it automatically allows you to drill down. So if you think about it almost like Google Earth, where you see the world, you zoom in, you can see UK, you can see London, you can see where we're sitting here. In that way, it's analogous, but for data. So in the middle of the wheel, you have all your data, and then I'm in this entertainment and comic books, and the DC comic books, and the Marvel, and the Spider-Man, right? And so the idea is
every time you're clicking on a cluster there, you can't. So the documents in that cluster are shown up on the left side there, basically. And this was built without any human intervention, by the way. The technology just got a bunch of documents and put them in categories, multi-levels deep, and then visually navigable.
So the API exposes this, so as developers we can access those subgraphs and do our own visualizations as well.
Yeah, we also give you access to the words. Do a quick search real quick, just to show them the words.
So,
Wikipedia, Star Wars maybe or something like that.
Star Wars is fun.
So that's not Wikipedia.
So if you type in Star Wars, right, over here on the left, you can see the system knows that Star Wars is associated with Star Wars, Return of the Jedi, Jedi, Revenge of the Sith, Phantom Menace, Darth Maul, for those of you who right? Skywalker, right? But the idea in this interface is similar to before in that you can actually say what's more or less important to you. So if I say, Skywalker is more important to me, you can increase the relevance all the way to the point where you drag it all the way to the right. It becomes required versus desired.
But one of the things to answer your question is you get that in your API, the ability to put in a query, whether it's a corpus of text or a word, and get back related terms.
So you can go back and direct a graph.
Yeah, and you can even build a graph on. Are you doing that now?
Yep.
Okay.
So, once you go through and you identify a set of documents, you can rebuild the wheel. You can see this gear shift going up at the top. It's working to the point where the checkbox appears, and now if I click on it, you end up with a wheel now just built on Star Wars information as it relates to Skywalker, right? But really good at helping an end user, kind of a researcher, to understand kind of this huge expansive piece of data, allow me to limit that down and then build some interesting kind of visualizations around it.
My last question is about data privacy. If you're searching, what's your policies in terms of do you mine these searches? Do you add it to the sort of central intelligence, or can you keep your searches and your information private?
Yeah, we're kind of big on privacy. What it does is it just changes your experience with the product. If you're using the product simply to find documents and store them in a bucket, you don't want that bucket to maybe share with anyone, or you don't want to collaborate on the bucket, you can do that. You can do that. We're not taking your stuff and doing anything with it and showing it to other people. Obviously, the real power of the product is in connecting. It's creating a level of connectedness that may be unprecedented, whereas you do things and put things together, it's going to connect you initially with things that are related. But where we're headed with this is, imagine if everyone in here was using the product and had their interests and things like that, and you choose which ones you want to be discoverable of your interests. But then, as we're working, I might be highlighting a paragraph on something really interesting to me, and one of your collections might show up as related. So as a user, it's a bonus for me because I just found a socially curated collection of 10 documents or 100 documents that's really related to something I want. And I can connect with that person if I want to, because they obviously share an interest that I have.
Do you mind saying a couple words about, in terms of, if you're writing a document, new functionality in terms of, for the bloggers?
Yeah, so a lot of bloggers, we love bloggers. Publishing is going to become really interesting with BrainSpace. So again, we're putting out a tool. It's going to be free. This will be very early next year, January, February. And you'll be able to help us fine-tune it if you want. But we have the vision for publishing, which is really interesting. When I say publishing, by the way, I don't just mean big publishers. I mean blogging or microblogging, or you sitting at your desk. So if we assume we now have thousands of users, maybe tens of thousands, or hundreds of thousands, or maybe a million users eventually, as you're typing something, Rocket will look at what you're typing and give you a number as the people that would be interested in that as you're typing it. So you can start to see what collections this would fall into when you hit publish. So it completely turns it around when you think about it. Right now, again, state-of-the-art of search is we put a bunch of documents in a database and they're waiting to be keyword searched. That's the state-of-the-art today. We flip that around 180 degrees. We take the entire corpus of text out there. We bring stuff down from tweets and documents down, and we're learning from that. You get to access all that knowledge. And as you're publishing something, and any side of Rocket, you're able to do this, by the way. You can just pull it up here. Is that it? Yeah. It's a real simple text editor, basically. You can put a title and put some text down. But the moment you hit publish on that, if you want to, it can be something you just have for yourself. It's private, right? You're keeping your own, we call a Spark file of things you're thinking about, right? You can do that as well. One thing you can do is publish something, put it out, maybe it's a paragraph or so, and you'll find collections of people that are interested in it. Yes.
Hi. This is really impressive, all the technology that you've shown. I had a just point to make. Jeff Jarvis made this point previously, which is that unadulterated serendipity may not be actually useful for anyone because I like context. So guided serendipity might be useful. So when I put in, so I've used other semantic search to curate the news for me. And when I put in the term aging, well, I'm interested in molecular biology of aging. I get bridges in America that are getting old in my newsfeed. Also, if you do that in PubMed, you only get, depending on the spelling that you put in, you get the type, so with the E or without the E, you get those kind of, so I'm assuming that you have solved those problems.
Yeah.
The thing that I was going to, the question was about is the knowledge graph that you showed. For scientific papers, can you tweak it based on certain methods, like or certain types of treatments? For example, randomized control trials or double blind. I mean, you prefer to get that data and qualify that data, so kind of giving it a metric dynamically.
You're hitting on something that's really important because if you think about the news products that are out there, some of them ask you to subscribe to categories. Right? Well, that doesn't mean anything to me typically because my categories are just not exactly what they want them to be. And so one answer, this is the first question you asked, is that inside of Rocket, and you saw on the screen there that you get to create your collections on anything you want them to be about. If you have documents, and even if there aren't any documents on the web or anywhere about the things you're interested in, you can just type them and put them in your collection. You can create your own collection on your own thoughts. It's real important that we think that people have that freedom to kind of create collections on exactly what they're looking for. So we're not even going to have the option in the product to subscribe to existing collections. It's not going to happen. We're not going to build them at all. Rocket is completely built by users and their interests and their the nuances of their interests is what you're pointing to.
You have the ability, two levels of control. You have the ability to like or grok a. You have the ability to grok any document, right? So these are things I like more. These are the things, and discard others. These are the things I don't like. Through this search interface, and this is meant for a user that requires more control. When you type in a concept like volcano, right, and it understands all these words and phrases are associated with volcano, you'll be able to drag things left and right, get rid of things that aren't as important, increase the relevance around things that are more important. And that's important for the user to drive that control as well.
And this will be like a Rocket Pro, basically, where we let people interact with the brain. That's going to be the kind of the upgraded version of Rocket. Did I answer your question? I think we danced a little bit around it.
The last one was about the knowledge graph, which was basically kind of tweaking it based on the methods and the materials used in the experimental in the experiments.
Yeah, absolutely. And then, well, I already said that. Any other questions over here? Oh, was that yawning? Sorry. Too many women. Yes.
Do you see BrainSpace as a personal tool working to interest you, or
yes,
are you aiming to be more like Google?
We get asked that question a lot. I don't have an exit strategy. Right now we're doing something we really love. We've been especially Chris and I have been working on, what you're seeing today is actually something we've been thinking about for like 7 years. And you know, in our last company, we got it part of the way there, but we weren't able to have the scale that we have now. I mean, now that we can scale the brains to hundreds of millions of documents, that gets really interesting. You know, you could have a science brain. Like, what if we could talk? Everyone can say, don't give us your documents. Let's play a game here at the publishers. We won't give away your documents, but can we build a brain of all that content and have that brain help people discover your documents? You know what?
That's valuable in your personal interests and your professional interests, right? And we're very passionate about that, right? So Rocket will be available for free on the web, and so that individuals will be able to sign up and enjoy the experience, right? We expect that those individuals will share with others and share collections, and it could be amongst friends, it could be amongst your religious community, it could be professionally motivated, right? And so those collections will kind of, and groups of users will naturally organize themselves.
Yeah, there's going to be a groups function in Grok, which will allow you to not only share with other people, but allow you to create pages with multiple collections that are shared by one group. You know, so you could have one group that has like 5 or 6 collections of documents together, and you're all curating those collections together. But it's a Grok group, basically. Everything about the technology and the product encourages people to have social activity with content. Like I said before, I think what's interesting about whether it's a small group of 5 people or it's a massive enterprise, what makes that group valuable is the knowledge that the people have and the sharing and the activity and the attention on that knowledge. And this platform is starting to really focus on those things. So we think we've really mastered the context part. You know, BrainSpace is wonderful on that. To give you a little bit of a peek, some of the things we're coming up with, you know, now are going to focus a lot on just the attention piece. You know, like, here's a question for you. Let's say that I found a tweet that was really interesting. What if I could put into a system, you know, I'd like to know, stumble upon other things that other people who like this tweet liked, regardless of the words. If the tweet just is an object, what are the sharing patterns that happen with that tweet? Are there other things that have that same pattern? That's where you have like serendipity, you know, where you can actually have an engine that's showing you serendipitously things that other people that kind of think like you are also interested in, regardless of the words. Those are the kinds of things that we're really interested in, kind of mashing that stuff up.